Hello class, welcome to scientific notation and how to do scientific notation. I'm going to start with large numbers and then we're going to go to small numbers, right? So my large numbers, and when we do large numbers, we try to make them to be able to read or be read very easily, very quickly. Okay, I should be able to look at it within 1 second and know that it's a very large number or a very small number. Okay, so if I've got 93. Okay, right now, if I've got 93,600,000, right, notice I just assume there's a decimal point. And if there's no decimal point listed, right, I can infer that there is a decimal point to the right of that number since it's really large. And notice we need to move it to the left. Okay, by moving it to the left, you want it to be in between a number that is 1 and 10. Okay, that way it's very easy to read. The number's not too small, but it's not too large. So from 93,600,000, I conclude that my scientific notation would be 9.3, notice the numbers between 1 and 10, right, times 10, and it's going to be a positive to the positive power because I moved my decimal point to the left, and also because it's a large number, okay? So at that point, 1, 2, 3, 4, 5, 6, 7. So you have 9.3 to the 10th times 10 to the 7th power. And at that point, that would be correct for that one. At that point, we can do another one, another example. Okay, say we've got 634,000. Okay, notice I'm inferring that my decimal point's right there. Notice I moved my decimal point to the left 5 spaces. Okay, so your answer would be 6.34 times 10 to the 5th. Notice I did not drop off the 0.34. Okay, you just can't, I say 6 times 10 to the 5th, right? That's a completely different number because you can't leave out 34,000 people, right? So remember that you need to write as many numbers as there are, not dropping off that 0.34. Okay, so you need to remember 634. So if it's a non-zero digit, please include it in your scientific notation. Okay, now we're moving on to small numbers. Let's go to small numbers and draw a line right here. For example, staying with the 6 number, notice a really small number, okay? And at this point, we're going to have, since the decimal point's here, we're going to have to move it to the right. Now notice if I move it to the right, I'm going to have a very small number. I'm also going to have a negative, okay? So at this point, you have 6.13 times 10. Notice I moved it to the right 3 spaces, so it's going to be to the negative 3rd power, okay? So if I'm moving it to the right, it's a negative integer. Okay, let's try another one. Same concept, right? Moving it to the right. Notice I'm still staying between the 1 and the 10, okay? So at that point, you've got 8.13 times 10 to the negative, right? Because I'm moving to the right. 1, 2, 3, 4, negative 4. Okay? So keep that in mind when you're doing this worksheet, whether you have to move the decimal point to the right or to the left, okay? Keep watch for that. Also make sure your integers are between 1 and 10, okay? So don't try to make it 0.813 because that number is between 0 and 1, not 1 and 10, okay? That number's too small for me to figure out, especially if we're doing measurements and in labs, so keep that in mind. If you need any extra information, please send me an email or come see me in the morning at 7:30.